Hey guys, today we're going to dive a little bit deeper into factoring. The last video that you watched was on factoring the GCF out of a polynomial. Today we're going to be factoring trinomials when a equals 1. Eventually, your first step to factor any polynomial, as I had mentioned in the last video, is going to be factoring out the GCF. We won't need that today, I'll explain that in a minute, but you will need it on Monday, so don't forget about it. So today we're factoring trinomials when a is 1. You guys are probably thinking, well, what does a mean? The trinomials are all going to look like this. ax plus by plus c. That's kind of our standard format. A is going to be our leading coefficient, and in the ones we're working with today, we're going to have a squared term here. So a is our leading coefficient, and it has to be 1 in order to use this method. On Monday, we're going to be working with ones when a is not 1. That'll look a little bit different. I gave you some examples of what we're working with today and what we're not working with today. So a being 1 in this example, the leading coefficient, it's not even written, it's invisible. A is 1, so we're able to use this method we're learning today. Same with this one, a is 1. Over here, I have an a of 5 and an a of 2. So there's a different method, a split method it's called, that we're going to be doing on Monday. So a has to be 1 for this method. You'll hear me reference that a lot more in the videos coming up. So the first example that we're going to be working on, and our goal for all of these is to be unfoiling. We are undoing what we had learned how to do last week. So to unfoil, the first thing that we're going to do is write out our parentheses. And the parentheses are going to look like that. And we're going to take our variable and write it as the first term. So b is our variable. I'm going to write those out. And I'm going to solve something called an X puzzle. It looks like this. As you get more comfortable with these, you may choose not to use it. For now, I suggest using it. It's just kind of a way to organize your thoughts and figure out what we need to figure out. And with this X puzzle, what we're looking for is what two numbers multiply together to give me the top number and add to give me the bottom number. And you choose where these, what numbers go where by this middle term. Your b term goes on the bottom, b for bottom, and the c term is just going to be your constant. That's going to go on top. So looking up here again, the b goes in the middle, or excuse me, the b goes on the bottom, b for bottom, and c is going to go on top. And we are looking for what two numbers multiply to give me the top, so multiply to give me that 7, or the constant, and add to give me the bottom. So I like to, this is an easy one, as they get a little harder, I like to write my factors out of the top number. So for 7, 1 and 7, and those are the only two that are going to work, it's prime. So I can fill those in here, 1 and 7, and 1 times 7 is 7, 1 plus 7 is 8. So step 3 is just going to be fill in those numbers. I have a positive 1 and a positive 7. And you have factored that trinomial. You are done. Step 4, I'm your math teacher, so I have to tell you to check it, although you all tell me that you don't. You can refoil this, or you can foil it for the first time and see that it actually comes out to this trinomial. So if you're foiling here, first is going to give you b squared. Outside is plus 7b. Inside is plus 1b. And last is plus 7. When I combine these, combine like terms, my middle terms, it becomes b squared plus 8b plus 7. So that checks out. That trinomial, when I foiled it, ends up being what I started with. So our answer here would be b plus 1 times b plus 7. It does not matter the order you put it in. I get that question sometimes. You could put the 7 over here, the 1 over here. You can flip-flop them here. It doesn't matter. We are multiplying, so the order doesn't matter. So I'm going to do the top 3 with you if you're following along in the notes, and then I'm going to have you try the bottom 3 on your own. So for the top 3, I have a squared plus 10a plus 21. So the first thing I'm going to do, I'm going to write out my parentheses to set up the binomials. My variable is an a, so I'm going to write a and a. I'm going to set up my X puzzle. I had set it up for you in the top one. So my X puzzle, the b term is going to go on the bottom, b for bottom. The middle term is my b. I'm going to write 10 down the bottom. And 21 is my constant. That's going to go on top. So I need to figure out what two numbers multiply to get 21 and add to get 10. So I'm going to list my factors out. 1 and 21, that's definitely not going to work. 2 does not fit into 21. 3 and 7 would be my next pair. Well, 3 times 7 does equal 21, and 3 plus 7 equals 10. So those are going to be my factors I'm going to use. and I can fill them in here. I have a positive 3 and a positive 7, and you would be done. That is factored. For the next one, we'll do 2 more examples together. If you feel like you got this, then you can go ahead and skip this part and go to the ones where you're trying on your own. If you need a few more to understand, that's completely fine. This one's p squared minus 3p minus 10. So I'm going to be dealing with some negatives for this one. So I'm going to set up my parentheses. I have a p for my variable this time, and I'm going to do my x puzzle. Now c is the constant that's going to go on top. I have a negative 10. Make sure you include that sign. The bottom is going to be b for bottom. So negative 3 goes on the bottom. And I'm still going to write out my factors as if they're both positive. I'm just going to write out 1 and 10, 2 and 5. And I need 2 numbers that are going to multiply to negative 10 but add to negative 3. So I know to get a negative number, I need to multiply a negative times a positive. So I'm going to fill in my 2 and 5. I know 1 and 10 won't work. And 2 times 5, that gives me a positive number. So I need to make one of those negative. Now to determine which one is going to be negative, I need to see where I can put my negative on the 2 or the 5, because I need it to be a negative 3. So 2 plus negative 5 is negative 3. So my negative is going to go with the 5. So then just to double check, 2 times negative 5 does equal negative 10. 2 plus negative 5 does equal negative 3. So my answer here is going to be p plus 2 and p minus 5. And you're done. I have one more to do together, and then you guys can try some on your own. For this one, my variable is c, so I'll set up my parentheses using a c. I'm going to make my x puzzle. The b goes on bottom, so 10 is going to come down here, and c on top, negative 11. So what 2 numbers multiply to make negative 11 but add to positive 10? So I'll write out my factors, and that's easy because it's prime. 1 times 11, that gives me a positive 11. So again, I'm going to watch out for those negatives. I'm going to fill my 1 and 11 in. And to determine which one I'm going to make negative, I'm going to look at my bottom. For this to be positive, my negative would need to go with the 1. And just double check again quick. Negative 1 times 11 is negative 11. Negative 1 plus 11 does equal a positive 10. And I can fill those in to make my 2 binomials. And you would be done. So at this point in the video, I'm going to show you your 3 examples. If you have the notes, it's just the next line, the next 3 down. But I will let you, if you don't have the notes, copy them down. I have z squared plus 7z plus 12. D squared minus 5d minus 24. And s squared minus 3s minus 18. So at this point, guys, I want you to pause, try a few on your own, make sure you got a hold of what's going on, make sure you have your negatives in the right spot. So pause now and try those, and I'm going to shine the answers up now. And I have my work with it as well. So for the orange one, the first example, it should be z plus 3 and z plus 4. For the green example, I have d plus 3 and d minus 8. And for the last example in pink, I have s plus 3 and s minus 6. And the next thing we need to do is going to build off what we did yesterday, or the last video you watched, I should say, factoring out the GCF. We are going to solve these now. So basically we're going to do what we just did to solve. Sometimes it's called find zeros. We're going to do what we just did, and we're going to use the zero product property to set them equal to 0 and find out where this graph is going to cross our x-axis. So I'm going to do 3 examples out with you again, and then you guys can try some on your own. So for these, I'm doing the same thing I did before. I'm going to write out my parentheses. My variable here is an x. I'm going to do my x puzzle. My 4 is going to go on top. 5 goes on the bottom. Notice how this is set equal to 0 for you already, just as something to watch out for. You did think about this in the other video, but let's just say this was x squared plus 5x equals negative 4. Remember, the first step to any factoring is going to be to move that constant over. So you would add 4. those two are equivalent polynomials, so be sure that you watch out for that. And so let's get back to this. For this one, I have my 4 on top, my 5 on bottom, and I need to multiply to get 4, but add to get to 5. So for this one, I'm going to go ahead and write out, well, 1 and 4. And I know right away that those are going to be my factors. 2 and 2 will not work to add to 5. So I'll fill those in my X puzzle. 1 times 4 is 4. 1 plus 4 is 5. So I'll fill those in. We have plus 1 and plus 4. And we're going to set these equal to 0, because this is really, I should have that in there. That equals 0. So I can go ahead and split this, just like we did with the GCF. We split our factors up, and we're going to set each one equal to 0 separately. So I have x plus 1 equals 0, and x plus 4 equals 0. And when you solve these, you'd subtract 1 here, you'll end up with a negative 1. And you'd subtract 4 here and end up with negative 4. Now what that means when we graph it eventually, if we graphed this, if we knew how to do it today, this is going to cross my x-axis at -1 and -4. Let's go ahead and do 2 more, and then you guys can practice 3 on your own. For this one, my variable is b. I'm going to go ahead and set it up, b and b, and I'm actually going to set it equal to 0 that time for you guys to show that out properly. I'm going to go ahead and do my x puzzle, and my x has a -7 on top and a 6 on the bottom. So I'm looking for what multiplies to -7 but adds to +6. So 7's prime, I know it has to be 1 and 7. To determine which one's going to be negative, I need to look at my bottom number, and I know that I need to make the 1 negative, because 7 plus -1 gives me a +6. So I have a -1 and a +7 to add to make my binomials, and I can go ahead and split. I have b minus 1 equals 0, and I have b plus 7 equals 0. So now when I add 1 here, I'm going to solve them separately. When I add 1 here, I have +1. And here I would need to subtract 7 to end up with -7. And it would be done. So one more example, last but not least. For this one, I have an n for my variable. I'm going to set it equal to 0. And I'm going to go ahead and do my x puzzle. I have -6 on the top and a -1 on the bottom. So to write out my factors, 1 and 6, well, that's not going to work to get me to a -1. 2 and 3 are also factors of 6. Those are going to work to get me to -1. So I'm just going to write them out positively. And now I'm going to use the bottom to determine which one is going to be negative. If I'm looking at this, I need a negative number, so my larger number needs to be negative. So 2 times -3 is -6. 2 plus -3 is in fact -1. So I'm going to fill those in. I have a +2 and I have a -3. So I have my 2 binomials, and I'm going to split them because it's already set equal to 0. So n plus 2 equals 0, and n minus 3 equals 0. When you solve these, you're going to subtract 2 to get -2, and you would add 3 to get +3. Again, remember, if I asked you, this is not in your notes if you're following along, if I said, hey guys, why don't you go ahead and factor this problem here? If I said to factor that, remember that first step to factor any polynomial is to set it equal to 0 first. So the first step here would be to move that over to end up with x squared plus 2x plus 10 equals 0, because we'd be adding the 10 to move it over. So be careful with that. All these examples that I was showing you are already set equal to 0 for you. So now I have the final 3 try on your own. I'm going to show you those. I have them in orange, green, and pink again. So the orange one, this is set equal to f of x. Remember, that's just equal y. You can kind of replace that with a 0. Don't pay too much attention to it. It's just another notation to show you guys. So I have x squared plus 2x minus 15 in orange. I'll write these down at home if you don't have the notes printed out. I have x squared plus 9x plus 14 in green. And then in pink, I have x squared plus 7x plus 10. So if you're following along at home, here's where you're going to pause. You're going to try those 3, and I'm going to show you the answers now. So in orange, I end up with 3 and -5. Now, if you didn't get that, I showed my workout, so pause your screen so you can kind of see what I did, and then you can check against your work. So 3 and -5 in orange. I have -2 and -7 in green. And I have -2 and -5 in pink. So go ahead and try the form on your own. In the notes Google form that you're filling out today, I'm having you do a few X puzzles to make sure that you guys know how to do those solidly before moving on to actually factoring on your own tomorrow. So let me know if you have any questions. I'm looking forward to seeing you guys in a Zoom on Friday. Bye for now.